Delaware Tech, Chem 100, Chem 110, Unit 2 continued, physical versus chemical changes, physical versus chemical properties. So when we're talking about the types of changes that can occur in matter, we have two different types of changes, physical changes and chemical changes. And physical changes are changes that occur without changing the composition of the substances or the mixture of substances. In other words, we're not changing the chemicals that make up the substances. We're not changing the formulas of those chemicals. We're merely changing how it looks. So, for example, steam and ice are both water. So if you go from water to steam, or water to liquid water to ice, or even ice directly to steam, these are physical changes. In fact, all the state-to-state changes that we talked about in the last module are physical changes. Melting, freezing, boiling, sublimation, etc. These are all physical changes. You can have other physical changes that are changing the appearance without changing the chemicals, the chemistry of the substances. Crumbling paper, filing a nail, putting water on sand. You're just wetting the sand. There's no chemical reaction. Grinding sugar into a powder, evaporating liquid nitrogen, melting steel, subliming carbon, so that's heating carbon up and making carbon vapor, depositing of gold plating. We talked about that in the last module. These are all changes of appearance or changes of state, so they do not change the chemicals. If we change the actual formula, in other words, we're creating a new form of matter, a new substance or new group of substances, mixture of substances, then it is a chemical change. Now, sometimes you can get both, but if it's both, we call that a chemical change. So examples, iron rusting. Iron is turning into iron oxide. That's a different chemical. Gasoline combustion. We are burning gasoline to produce carbon dioxide and water, and we're burning gasoline in the presence of oxygen. This is a chemical change. Anytime you burn anything is a chemical change, whether you're burning it by setting it on fire or you're burning it as in part of your digestion system, as in burning fat or burning carbohydrates. Batteries charging. Batteries frequently involve different types of salts. I know we use the word salt to mean table salt that we use on our food, but to a chemist, salts is a large category of compounds that are composed of ions together, and batteries charging change the composition of those different compounds or ions of the compounds. So those are chemical changes. So let's try a quick little quiz here. Which one is a physical change? Which one is a chemical change? And if it has a chemical change in it, we'll just call it a chemical change. So melting iron bars. Well, this is a change in state. You're going from solid to liquid, therefore it's a physical change. Burning wood. Well, you're adding oxygen to the chemicals that are in the wood. You're setting it on fire. There's a clear chemical reaction. How do you know there's a chemical reaction? Well, you're turning what was the wood and the oxygen gas into ash and smoke and maybe some other particulates or other compounds. You'll smell some things coming off. Carbon dioxide vapor will come off. Water vapor will come off. So that's clearly a chemical change. Milk spoiling. Well, anytime you have spoiling, that's going to be the result of some microorganism growing on your food. Well, it's digesting the food just like we would, so those are chemical changes as well. Condensing steam onto a glass. We talked about this last time. When you have water vapor in the air and you have a glass of ice water, the surface of that glass is very cold, and you will condense the water vapor in the air right on the glass. Well, you can do this with steam as well, and this is just a physical change of going from vapor or gas to liquid, so that's physical. Decaying of leaves. Decaying, just like spoiling, just like digesting, these are chemical processes. Mowing the grass. Well, you're just cutting the grass. There might be some chemical changes when you cut it, but let's just talk about the mowing action itself. That would be physical. Chewing gum. Well, just the chewing part of the gum, if we're only talking about the chewing, not the actual digestion of the gum in your mouth due to the saliva, due to the enzymes in your saliva, well, that would be a physical change. Of course, eventually you will digest certainly the sugars in the gum, and those would be chemical changes. Digesting lunch, well, this is clearly a chemical change. You're turning your food, your carbohydrates, your fats, your protein, you're eventually turning them into carbon dioxide and water in a slow burn process called digestion. That's a chemical process. In fact, it's actually dozens of chemical processes. Subliming dry ice. You're going directly from solid chunks of dry ice to carbon dioxide gas, carbon dioxide vapor. That's a physical change. Separating vodka into water and ethanol. Well, vodka contains water and ethanol. That's a mixture. And you only need physical means to separate mixtures. You're separating two completely different substances, water, H2O, and ethanol, C2H5OH or C2H6O. You're separating these two. You can do that with physical means. Separating carbon dioxide into carbon and oxygen gas. Well, now you're talking about actually breaking the chemical up into its component elements. So you're taking carbon dioxide, which has one atom of carbon and two atoms of oxygen. That's a single molecule, and you're breaking it up into its components. Well, therefore, you're changing the chemical itself, and that would be a chemical change. Let's look at properties of matter. So we're talking about physical versus chemical properties. And the physical versus chemical properties are very closely related to physical versus chemical changes. It's just these are static properties of matter. So we're looking at things that you can actually quantify or describe that relate to the matter. So a physical property is a property that you can measure without changing the substance, just like a physical change. What would be examples? Well, you can tell what the color is without changing the chemical. You could put it on a balance and measure its mass. You could put it in a container and measure its volume if it was a liquid or using other methods. You can measure its density, and density, we'll learn later, is just mass divided by volume. So you can measure those without changing the chemical. You can smell it. You can melt it and measure the temperature that it melts at. That's the melting point. You could freeze it. You could take the liquid form and turn it into the solid form and measure that temperature. And I will tell you the melting temperature going from solid to liquid and the freezing point going from liquid to solid are almost always the same temperature because it's the same transition. There are times where it's not exactly, but for your purposes, the temperature of both transitions that are just opposites of one another will be the same temperature. Malleability. Malleability refers to how flat you can hammer it, how easily you can hammer something flat, like gold metal. Gold metal is one of the most malleable of all substances. Malleability comes from the ancient Latin word malleus, and if you're taking anatomy and physiology, you might remember that the hammer bone in your inner ear is called the malleus. Well, malleus is just Latin for hammer. So malleability literally means the ability to hammer flat. And gold can be hammered incredibly flat. You could take a very small piece of gold and hammer it to cover a very large table, for instance. Gold can be pounded so flat that you can make it as thin as about 700 atoms. 700 sounds like a lot, but that's an enormously small number of atoms. Crystal structure. You can always look at the crystal structure with high-power magnifying glasses or microscopes like electron microscopes. You can look at the crystal structure without destroying the chemicals. Specific heat is a property that we'll talk about later at the end of this unit. And specific heat is how much heat you have to put in to an object to raise the temperature up. And you can do that without actually changing the chemical. You can warm up iron and without changing it from iron to something else. So that's a physical property. Chemical properties are properties you can only observe by basically destroying that chemical, changing it into another chemical. So flammability, obviously we're setting it on fire, we're igniting it, it's reacting chemically with oxygen gas and producing new chemicals. If we were burning carbon compounds, we would produce carbon dioxide and water, totally different substances. Reactivity to water. There are certain chemicals that will react with water, some very violently with water. All the metals on the left side of your periodic table, lithium, sodium, potassium, rubidium, etc., react quite strongly, quite vigorously with water. In fact, as you go further down the table, they explode with water, so they're very reactive. They form new chemicals, so that's clearly a change in, that's a chemical change, and how reactive it is, that would be a chemical property. So heat of formation. This is how much heat is generated when you make a chemical. So the only way to measure that is to take some chemicals and turn them into other chemicals. And therefore, that's a chemical change. And absorbing how much heat is related to that change, that would be a chemical property. So you see that each of these chemical properties is actually related to a chemical change, but it's a quantitative or very descriptive way of describing that change. Therefore, we would call it a chemical property. The heat of combustion, how much heat is generated when we set something on fire. And different chemicals produce different amounts of heat. That amount of heat is a chemical property. The fact that it combusts at all, that's a chemical change, but how much heat comes off, that's an amount of something, therefore that would be a property. Explosiveness. How explosive is it? Is it not explosive? Is it mildly explosive? Is it extremely explosive? That's a chemical property. Of course, the actual explosion is a chemical change. Solubility under some circumstances is a chemical change, and therefore how soluble something is would be a chemical property, and that only pertains to salts, various types of salts. We won't go into that right now. This really comes up in Unit 7 when we talk about solubility. pH also is later on when we get to Unit 8 on acids and bases, but this is the result of H pluses being released. These are hydrogen ions being released from an acid, and therefore that's a breakdown of the acid into its components. So pH is a chemical property based on a chemical change. That you won't be responsible for in this unit, but we'll talk about that later. So, a little quiz on physical versus chemical properties. Remember, physical properties are properties you can measure without changing the chemical. You can change its appearance, its physical state, but you can't change the chemical. Then it becomes a chemical property. Freezing or melting point of iron. In other words, what temperature does it become a solid at? Well, that's clearly a physical property. We don't need to change it. It's still iron, whether it's melted or whether it's solid iron. Flammability of cellulose. Cellulose is the main component in paper. We get it from trees. Cellulose is one of two major components that makes up wood. Cellulose and another compound called lignin, which is a very complex compound. Cellulose is a polymer, a naturally occurring polymer that plants make. We can't break it down in our bodies, so when we eat it, it's called fiber. But you can set it on fire if you have pure cellulose. It's like burning paper. And obviously, this is a chemical change. Determining the mass of a diamond. Well, I can put it on a scale and measure it without changing its chemical structure. Therefore, it's a physical property. Flash point of ether. Now, flash point means the temperature that has to be reached in order for something to even ignite. In other words, for the vapors to be ignited. So ether is a very, very flammable compound. Even at the lowest temperatures, you'll get vapors coming off, which is a physical change. But the second you ignite it, now it's a chemical change. You're burning the ether. It becomes carbon dioxide and water. And the temperature that will allow this ignition to occur, well, that's a chemical property. Ductility. This is another word like malleability. Ductility is a word that means how well you can draw it into a wire. It comes from a Latin word from the prefix duct, which actually means to draw something. I don't mean draw like draw a picture. I mean draw it as in pull it and so that it draws out into a long, thin piece. So in this case, it means drawing it into a wire. Copper can be drawn into a wire very easily without changing the copper. It's still copper while it's a slab of copper, and it's still copper when it's copper wire, so that's a physical property. Tensile strength of nylon. This is how hard it is to break a strand of nylon. So you can break the strand of nylon, but it's still nylon when you're done. Digestibility of protein. You're digesting it. That's a chemical change. So how digestible it is a chemical property. Sublimation point of carbon dioxide. At what temperature will it go directly from solid carbon dioxide, what we call dry ice, to gas form of carbon dioxide? That's the sublimation point, and that's a physical property because that's a physical change. Reactivity of potassium metal with water. Remember I told you the metals on the left side of the periodic table, they're called alkali metals, by the way. Alkali metals frequently react very strongly with water, and potassium metal, if you put even a small chunk of potassium metal in water, it will explode. It's very, very reactive. It's a chemical reaction, and therefore how reactive it is a chemical property. Likewise, explosiveness of TNT, trinitrotoluene, is a chemical property because the trinitrotoluene, the TNT, reacts with oxygen in the air to break up into gases like carbon dioxide gas and water vapor and various nitrogen gases, and it does so very explosively in this very explosive chemical reaction. So that's a chemical property, how explosive it is. The crystal structure of ruby. Ruby is aluminum oxide with trace amounts of chromium. And you may not know this, but aluminum oxide crystals, they're called corundums. Corundums that are red because of trace amounts of chromium are called rubies. Corundums that are any other color, blue, clear, green, purple, they're called sapphires. So sapphires and rubies are really the same crystal. They just have different traces in them. Rubies are defined as all only the corundums that are red, and everything else are defined as sapphires. But to look at the crystal structure of ruby, you need a very high power microscope to look at that. You don't have to destroy the compound in the process, so that's a physical change, and we'll stop right here.